See, the next thing is about the comparison of surds. You may take it as 10th point. What it is? Comparison of surds. See, to compare the surds, if they are similar, then it is comfortable for all of you. Similar in the sense, if they are of the same order, then our task is somewhat simple. For example, if you have the numbers like square root of 17, square root of 19, right, square root of you may say some as 34. Automatically, what is your comparison? All are of the same order, second order, 17, 19 and 34. This 17 is the smaller one, 19 is the next smaller one and 34 is the next one. This is the way of comparison if they are of the same order. Right? For example, if you have that cube root of 1 by 16 and then cube root of 1 by 15, how to compare? Since both the surds are of the same order, you just compare in such a manner that this is of 1 by 16 and that is of 1 by 50. What to do? This 16 is smaller, 1 by 16 is bigger, 1 by 16 is larger than 1 by 50. So cube root of this 1 by 16 is also greater than cube root of 1 by 50. So directly you need to compare the surds with the order of the radicands which are there in the surds, right? But if they are not of the same order, then how to compare? For example, if you have cube root of 4 and fourth root of 3, how to compare? This is cube root of 4 and that is fourth root of 3. Where this value located and where that value located, you need to compare those two. So to compare those two, you need to make both the surds with the same order. Since this is cube root and this is fourth root, we are able to convert this cube root of 4 into different forms having the orders which are multiples of 3. And we have a chance to convert this fourth root of 3 into different forms whose orders are multiples of 4. But now to compare these two, we need a number which is multiple of 3 and 4 because we need to make same order. So what is the multiple of 3 and 4? That is 12. So since 12 is the common multiple for this both 3 and 4, I will convert this cube root of 4 into a surd of order 12 and this fourth root of 3 also into a surd of order 12. And if both the surds are in same order, then our task is easy. We will compare directly. So for that, what I am going to do is, you just convert this cube root of 4 and then fourth root of 3. Yeah. See, this cube root of 4 and then fourth root of 3. To compare, convert them into a surds of order 12. So to make this 3 which is in that cube root, see this 3 as a 12, you need to multiply with 4, right? So it can be written as 3 into 4th root of 4 power 4. Since we are multiplying here with 4, you need to raise that 4 as a power of 4. And now you need to multiply here with 3. So you need to raise this 3 also as a power of 3. So 4 into 3 with 3 cube. Now this is 3 into 4 which is nothing but 12th root of 4 power 4 is 256. Okay, 4 power 4, you need to multiply for 4 times and that is 256. Now whereas coming to this situation, this is 12th root of 3 cube is 27. Now if you look, this is 12th root of 256 and that is 3 cube, right, 27. And that is 12th root of 27. See, if you compare, both are of the same order, 12th root, this 256 is larger, so automatically this is the larger value. So cube root of 4 value is larger than the fourth root of 3. So to compare two surds, you need to convert them into of this same order. So after the conversion, it is a direct chance to compare the surds, right? Just have a look. I will give you one more problem related to this comparison, right? I am erasing this. Just have a look. See, next problem, what I have in my hands is for that comparison. See, you may take it as cube root of 9 and then fourth root of 11 and then sixth root of 17. This is what we need to compare. The cube root of 9, fourth root of 11 and sixth root of 17. What is the order of surds? Either ascending or descending order, you need to decide. So for that, what you have the chance to make all these three surds into surds of same order. This is of order 3, this is of order 4, this is of order 6. So you need a common multiple for this 3, 4 and 6 to convert them into surd of same order. So the common multiple for 3, 4 and 6 is 12. Is it right? Since the common multiple is 12, so you just again common multiple is 12, right? Is there any other thing? So 12, you just multiply here with 4, then it becomes like again 3 into 4 with that 9 power 4. And here you just multiply with 3, 4 into 3 under that root, you just write that 11 also as a power of 3. Now you just multiply with 2, 6 into 2 root of 17 square. Now all these three surds are of same order. What is that order? 12. Since these three surds are of 12 order, just you compare the number which is given under that 12th root. See here the number is 9 power 4, there the number is 11 cube, and here it is 17 square. We know that 17 square is 289 and 11 cube is 1331, and you need to find the value of 9 power 4 also. And after finding that value, you just compare it. 9 power 4 is nothing but 81 into 81, right? 81 into 81 is almost 6000 something. So this is greater 1331, greater 289. The same thing will move up. Then this is the order of the given surds. Cube root 9, 4th root 11 and 6th root 17. Right? So this the way to convert the orders and then to compare the surds. Right? See, that conversion of surds is also helpful in multiplying different surds also. See, I will mention some simple problems related to that multiplication also. I am erasing this. And the next thing is related to that multiplication. For example, if you have that 7th root of, you may say 7th root of 3 into something like, for example, I am taking it as 8th root of 2. So if you wish to multiply the 7th root of 3 into 8th root of 2. Since you are going to multiply the 7th root of 3 into 8th root of 2, multiplication is possible only if the surds are of same order. Because the orders are different here, you need to convert them into surds of same order. So this is 7 and that is 8. You need to convert both the surds into same order. So the common multiple for 7 and 8 is nothing but 56. So convert this surd into a surd of order 56 and that also into a surd of order 56. So for that you just multiply this 7 with 8. Then it becomes like 7 into 8 of 3 power 8. Here we are multiplying with 8. So raise this 3 also as a power of 8. Into, now you just multiply here with 7 and then write that 2 also as power of 7. Now this is 7 8 56 and that is also 7 8 56, and now we are going to multiply these two again. Since both are of order 56, you just directly write it as 56th root of 3 power 8 into 2 power 7, and that is your answer. Right? If there is any further simplification, you move depending upon the numbers. Now here there is no other simplification because it is 3 power 8 and that is 2 power 7. Right? So now this is the way how to utilize the order conversion of surds and how to multiply, how to simplify and all these things. Right? And after this, I am going to introduce you the thing that rationalizing factor. Right? So the next point is the 11th one. The 11th point is the rationalizing factor of the surds. I am going to erase this. Just have a look. And the rationalizing factor concept is the important concept related to so many simplifications, and that rationalization factor concept is usually helpful in many other branches of the mathematics also. See, basically what is a rationalizing factor? See, rationalization and then rationalizing factor. So now I am going to introduce you the rationalizing factor. See, I have two surds. Say, if you say them as some x and y. X and y are two surds. If x and y are two surds, and on multiplication of this x and y, the result is a rational number. See, think once again. Since x and y are surds, x is rational or irrational? What you say? X and y are surds, then what is x? Whether it is rational or irrational. As we discussed earlier, if it is a surd, then it won't have any simplification to the rational number. Every surd is an irrational number, already mentioned. So since x and y are surds, so clearly x is an irrational number, y is also an irrational number. But if you multiply those two, the result should be a rational number. Right? What I am going to introduce you is the rationalizing factor. See, if x and y are any two surds, and the product of that x and y is a rational number, then we call these two x and y as rationalizing factors of one another. What I am going to tell you is rationalizing factors of one another. Since x into y is a rational number, we call x as the rationalizing factor of y and y as the rationalizing factor of x. What you say? So x as the rationalizing factor of y and y as the rationalizing factor of x if the product x and y is a rational number, right? So this is what I mentioned you, 11th point related to the rationalizing factors, very useful thing. So I am going to give you a few examples. If you think about what I am going to tell you, say something like root 2. See, if you multiply this root 2 with root 2, what you will get? Root 2 into root 2 is root 2, what you say? Since root 2 into root 2 is 2, 2 is a rational number, we multiply two surds and whose result is a rational number, so we call these two numbers as rationalizing factors of one another. So root 2 is a rationalizing factor of this root 2 and that root 2 is the rationalizing factor of this root 2. Okay? And I will give you, I will explain this with an example. A number will have many rationalizing factors. What you say? For example, what is the rationalizing factor of root 2? What is the rationalizing factor of root 2? Because root 2. If you multiply this root 2 with root 2, what will happen? If you multiply this root 2 with root 2, your result is 2. Is it right? 2 into 2. And then, if you go for the further value, this is root 2 square and this is 2. Now if you multiply this same root 2 with square root of 2 cube, what will happen? See, root 2 into root 2 cube can be written as square root of 2 power 4. Square root of 2 power 4. Under that square root you have 4 2's. Since it is square root, you need to write half of them out. It can be written as 2 square and that is 4. 2 square into 4. And if it is root 2 into something like, you may say this is only 1 to write. So to remove that square root, you need even number of values under that square root. So since this is 2 power 1, you may take some 2 power 15. So root 2 into 2 power 15 can be written as square root of 2 power 16. Since root 2 into root of 2 power 15 is root of 2 power 16 and your answer is 2 power 8. This is also a rational number. Like that we have many chances to write. Now if you compare all these things, since root 2 is multiplying with this root 2, your answer is rational number. This is rationalizing factor of this root 2. And since we are multiplying this root 2 with root 8, that is also a rationalizing factor. This root of 2 power 15 is also a rationalizing factor. So for suppose if you multiply this root 2 with the square root of 2 power 2019. If you multiply, your answer is square root of 2 power 2020. Here 2019 2s and there 1 2. And if you remove that square root, your value is square root of 1010. Clearly a rational number. Since it is a rational number, you may call this also as rationalizing factor for root 2. So at the end, what I am going to conclude you is, for root 2, there are many rationalizing factors. But among all those, if you think this root 2 is somewhat simple. But here there is no an exact meaning for the simplicity. Because some may tell you that, ask you that root 2 into 1 by root 2 is 1. So this 1 by root 2 is also mentioned as the rationalizing factor for root 2. Right? Absolutely right. So this is also one of the rationalizing factors. So for a number, for a surd, there are many rationalizing factors. But among all those things, usually we will consider this as the simplest thing, or you may go with the options. Okay, there is no an exact meaning for the simplest rationalizing factor. So at the end, what I am going to conclude related to this rationalizing factor is, you just think that if you multiply two numbers, if the result is a rational number, then these two are mentioned as the rationalizing factors of one another. For instance, I am considering the rationalizing factor, a simple number root 2. If you move with some other thing, see, I will give you different examples. Just observe here. After that, I will go for your doubts and I will end that session. See, if you think, look here. For example, I have cube root of say 5. See, what is the rationalizing factor of cube root of 5? Just have a look. Cube root of 5 into cube root of Just look here. This is cube root of 5 and this is cube root of 5 square. Since this is cube root of 5 and that is cube root of 5 square, if you multiply, it becomes like cube root of 5 cube, right? Since it is cube root of 5 cube, your answer is 5. So, product of these two is a rational number, that is 5. Since product of these two is a rational number, we call these two as the rationalizing factors of one another. So, for this cube root 5 rationalizing factor is cube root 5 square, and for that cube root 5 square, this is the rationalizing factor. Now, what do you say about this fourth root of 7? See, under that fourth root we have only 1 7, but to make it to get a rational number, you need to multiply this fourth root of 7 with fourth root of 7 cube. There is only 1 7, but we need 4 sevens to make it as a rational number. So I will write it like fourth root of 7 power 4, and your answer is 7. So what is the rationalizing factor of fourth root of 7? That rationalizing factor is fourth root of 7 cube. And rationalizing factor for this fourth root of 7 cube is fourth root of 7. And when it is coming for this situation, 7th root of 2. 7th root of 2. Under this 7th root, there is only 1 2. But we need how many 2's? 6 2's. So you just write it like 7th root of 2 power 6. So if you multiply these two, 7th root of 2 power 7, and your answer is 2. So for this 7th root, this is the rationalizing factor. You may call it as 7th root of 64. For this 7th root of 64, this is the rationalizing factor. These two are the rationalizing factors of one another. Like that, like this, we are going to find the rationalizing factors. And this concept of rationalizing factor is very helpful in simplifying many problems. That's why you need to discuss perfectly about this rationalizing factors. And at the end, I just mentioned one point and then I move for your doubts. See, if you think about one thing, for example, if you have that nth root of some a power, you may say it as some t. So what is its rationalizing factor? Under this nth root, there are ta's. If you multiply with nth root of a power n minus t, just have a look. Nth root of a power t into nth root of a power n minus t. Under that root, nth root I have a power t and a power n minus t. If you multiply, what you will get? Nth root of a power t plus n minus t is nothing but a power n, and your answer is a. Then rationalizing factor for this number is that one, and for that number is this one. You need to think in such a manner, right? And now this is something about the rationalizing factors, and from here onwards we will continue in the next class. Just have a look about this, and then you just raise your hand for the doubts.